Well, happy New Year to everybody. I hope you all had a nice break. I know it's kind of troubling getting back to school, but this is what we have to do, so we have to jump in both feet. And I've even dragged my feet getting this video out to you. So I wanted to review for Monday. Monday, these are the notes here that I showed to you on Friday, and I know a lot of you weren't there, and uh, some of you were there, just we were ready to get on break. So we are on chapter 16. We are talking about solids and crystals. And crystal gives like all these definitions, which is really important. And this amorphous solid, which is, but it says it doesn't have any crystalline structure to it. These are all great for the test. These are great information. Let's see here. These are some simple. This is the 3 cubic systems. They're not the only ones. There's like 7 of them, and I'll show you that in a bit. I wanted to show you something new that we didn't really talk about a whole lot last semester that we can bring in this semester. Um, so we have the simple cubic, the body center cubic, and then also the face centered cubic. This is where it really talks about those shapes and how they play a role, and it does depend on the atomic ratio, the size of the atomic radii, and how they compare to each other. Notice that sodium is about half the size as chlorine. And on these here, like cesium and chlorine, they are nearly the same size. So they're comparing the diameter to diameter, and it's 2 to 1 here for the sodium chloride. In other words, the chlorine is twice the size as 1 sodium, and here it's 1 to 1. And so what they've determined, it says the size of the ratio of the ions determines the type of packing. And so this here, you can see this is a 2 to 1 ratio, just like the NaCl. And so it would be a face-centered. And then this right here, the potassium fluoride, is nearly 1 to 1, so it'd be a body-centered. And we'll go more over those. We'll have more visual aids in class. But that's pretty much the idea. If you can follow these notes, I think that you'd be pretty squared away for the homework. There are some questions, but mostly this is the foundation of it all, the main idea that you should get, because we're not going to jump too far into it. Like I said, there's several others. We have the simple cubic, and they're talking about neighbors. So if you choose one atom, going back up to what a picture looks like, if I chose one atom, how many neighbors does it have? Now, this is a hard one to kind of judge. You can see, well, if I'm looking at this, this is like a closest neighbor, these closest neighbor, and then there's also these others on the other side, and they're kind of squishing down on it. That's what we need a visual for so that you can see it. But on this guy here, this was a face-centered, and the face-centered, you could see the FCC has 12 immediate neighbors. Now, with this one diagram here, it's hard to see 12. Like I said, when we get into class, we'll take a look at it. So this chart plays a big role, seeing like how these things are they packed in. So simple cubic only has 6 neighbors, body centered has 8, and face centered has 12. And this statement right down here kind of wraps it up. Face centered and this hexagonal closest pack, they both have 12 neighbors, and they are the most dense packings. And this hexagonal is a lot of metals. They fall into this category, and so it's a real close packing and has these neighbors, meaning the atoms themselves. We're going to heat treat something in class. I'll do it really quick, a paper clip right in class, and we can talk about that and what that means and how it rearranges the atoms and strengthens the material just by that rearrangement. And we talked a bit about like metal works and things like that. Here's your homework down here at the bottom. See a picture on page 318 for problem number 1. Okay, I don't want to skip over this stuff. This is all really important. This is your homework. However, there is something I want to show you. If you go back to the rules and guidelines, like remember the first day of school, here they are. If you don't have these, I'm thinking about posting these, and especially this link right here, this little link, which is really neat. And so if I click on it, it's going to open up. I believe I already have it opened up. Gives me this area here. It is the textbook. Some of the teachers put the textbook online. And you're probably thinking, no big deal, I have my textbook. And so it's kind of cool. But here's our chapter 16, solids. So with that, let me just kind of make it a little smaller so we can see the whole thing here. All right. Sorry about that. There it is. So now that it has all your readings and it has all these little charts and everything. And here's 16.1. Look at this. There's 7 crystal systems. That's really important. It shows you the cubic, tetragonal, hexagonal, rhombohedral, orthorhombic, monoclinic, and triclinic. Those are all the 7 crystal systems. That's all part of your homework as well. And it talks about the unit cells that we have here, and it talks about these things. We've just chosen these 3 because they're the most basic, and it builds from there. It just gets very complex and from there. This is an important one here. This is sodium chloride. One of your homework questions is based on this chart right here. It asks you to explain why sodium chloride is 1 sodium to 1 chlorine, and does it make sense based on this model. So I think by you looking at this, you'll see that it's the best way to pack this thing, because the sodium is so small compared to the chlorine, it'll fit in between each one of them. So it does make kind of sense there. It goes on, this is the closest packing, and that's where we got to as far as our reading for that day. And then it goes on to talk about these other non-metallic elements like carbon. It will talk about buckyballs and things like that. When we get to class, we'll discuss those, what they're talking about. And so it goes all the way through. You can read it. It's kind of, it's all in your book. This is just a copy of the book. It's put online. It's pretty neat. There are some textbook little things here. This is kind of cool. There are some other things as well on here. It will show you, like, these are the textbook assignments. Let's see if we can find our chapter. Yeah. So here's chapter 16. One thing it doesn't have on here is number 11. We'll have to take a look at that. Here's the question. From the photo of NaCl, why is sodium chloride the simplest formula? All right, so you can kind of use that if you need to, if you're in a pinch. Like I said, I'll put that link up there so that you guys can find it. I'm just going to scroll on back, get on back here. If I want to go back to, here we go, on my textbook, I need to go back and go to notes and lectures, and then go here. So if you're unsure, I went to the home page, and then there's this little unit finder, and if I click on it, it shows me this little, has like a little, it's like a PowerPoint, I suppose, really PowerPoint, but it's kind of like a neat little summary of the chapter as well. And again, here's the 7 basic crystal systems. And you can see a cubic, tetragonal, orthorhombic, and you can see the different shapes. It's kind of neat. It shows you all these different minerals as well. There's monoclinic, that's boron, that's element. And then rhombohedral, hexagonal, triclinic, and then it shows you these different ones as well. It kind of goes through all of them. So that's kind of the gist of the chapter. Like I said, we're just going to focus on the 3, the cubic and the body face and the face centered. So don't get too caught up in this, but this is a neat little link for you, and I think it'll be very helpful for you as you're going through the rest of the school year. So I'll be sure to get those up there. It is on, if you're wanting to look ahead, if you always forget where it's at, but it's going to be on the bottom of your rules and guidelines from the first day. Okay, kids, well, I hope this helps you out, and I look forward to seeing you tomorrow. Take care.